All right, for bell work today, we have 3 questions. Find the sum of the first 10 terms of this series, that series, and then simplify x plus 5 to the third power. I'll give you 3 minutes, and then we'll go over.
Oh my gosh. I'm so glad.
Yeah. All right. Does anyone have an idea of how to start the first one? We want to do a summation. To do the summation, we will need the formula for this series. We'll need this. What type of series is this? Did you say it, Ian? It's arithmetic. What do you add each time? 4. So for this one, our first number is 3. The common difference is 4. And then for an arithmetic sequence, the formula is dn plus your first term minus d. So for us, that would be 4n plus, well, actually really minus 1. 3 minus 4. Okay, then once you have this, you've got 2 options to find the sum. The first is you could do a summation from the first, I should use it at, from the first term to the 10th term of 4n minus 1. Or we have a formula where the sum of the first 10 terms is just 10 multiplied by the first term plus the 10th term divided by 2. You do either one of those. That's the first term. What? Which one? This one? 3 plus the 10th term, whatever that is. What is the 10th term? 39. So it'll be 3 plus 39. That's probably the easier way to do it. 3 plus 39 is 42, divided by 2 is 21, times 10 is 210. And if you type that into your calculator, that's what you should have got, 210. Yay? 210. Let's do the geometric one. What is the common ratio for each of these numbers? 2 times 2. So then our first term is 3. Our common ratio is 2. And for any geometric series, it's your first term divided by r times n, or sorry, times the r, not n, times r to the n power. So that for us, I would be 3 halves times 2 to the n. And again, you got two choices. Once you have your formula, you could just in a calculator do the sum of the first number to the 10th number of this formula. Or now the summation one for this one is a bit more complicated. It's a fraction of 1 of your first term multiplied by 1 plus r to the nth over 1 minus r. First term, first term, 1 minus r to the nth over 1 minus r. So for us to get the first 10 terms, we would do the first term 3, 1 minus 2 to the 10th over 1 minus 2. What is that? $3,069. Yeah. Okay. Jay? No, yeah.
So on the side, there's like the formula says n minus 1 instead of n. So what would we put for that?
That, I mean, the summation would be the same thing. How you write the original, I prefer this form. But if you do A1 R n minus 1, that's fine. 2. They are equivalent formulas. Because all I do is I take that r to the negative 1 and I actually write it as divide by r. Right?
Yeah.
Okay. I think if you try writing, have you tried writing it like this, like 3 halves over 2 to the n? Try that. I'll see if it accepts it. If it doesn't accept it, then there would be 3 times 2 to the n minus 1. All right, last one. We have to simplify this. This is a preview of what we're going to do today. So it'll be pretty exciting. We need to do x plus 5 times x plus 5 times x plus 5. How would we simplify those or multiply them together? Well, you would have to double distribute first. if you do that, you get x squared plus 5x plus 5x plus 25 are simply x squared plus 10x plus 25. I'm gonna have to erase. Let's continue this up here, up top. I'm gonna rewrite that up here. All right, is everyone okay with how we got x squared plus 10x plus 25? Double distributing x times x squared, x times 5 is 5x, 5 times x is 5x, 5 times 5 is 25. Combine your like terms. 5 and 5 make 10. Or my name isn't Mr. Lake. But it's a different class with Tristan's not here. Sure.
I wish Tristan could zoom. Why do they have these stupid rules?
I mean, she actually could zoom in.
Well, you can only do a certain amount of hours on Zoom.
Sure, but I mean, you could zoom in for your own educational benefit.
But that was what we're telling people, like, Zoom in for 40 hours throughout the entire school year.
Well, to count for, I think that's to count for attendance. You could, I think, maybe I'm just lying right now. I think that's to count for attendance. You could just zoom in just for the educational benefit of doing it for your own value.
I'm
Right.
about to tell Tristan to zoom in, just not even to pay attention, but just to, I haven't heard speaking on.
Sure. All right, we're ready for the last one. We've got one more things to multiply in. And again, you have to double distribute each of these three terms. So that's x squared times x squared times 5, 10x times x, 10x times 5, 25 times x, and 25 times 5. So that gives us x cubed plus 5x squared plus 10x squared plus 50x plus 25x plus 125. And then if you combine like terms, that gives us final answer x cubed plus 15x squared plus 75x plus 125. And there you go. That is simplified.
Oh my God.
Would you like to do x plus 5 to the 4th power? We would then have to quadruple distribute then. Or x plus 5 to the 5th? What about to the 10th? I know what you're thinking. There has to be a better way. And that is the binomial theorem. Ba, ba, ba. If you understand this, you will do a better job than 5 out of 7 of my AP calculus students. Then again, they didn't get this lesson. This was cut out last year. In their defense. All right, does anyone need more time to write? Then let us do the binomial theorem. And Pascal's triangle. And then using that to do binomial expansions. First, we're actually going to start with Pascal's triangle. I did put this on the board once, and then I said we would cover it again later. And now is later. All right, so for any binomial, which is binomial means you have two terms. If you want to raise those two terms to a power, what you will get is these answers listed for the first 7. X plus y to the 0, well, anything to the 0 power is just 1. X plus y to the first would be, well, you just distribute that power you could do. It's just x the first, y the first. This one you would have to do a double distribution, x plus y times x plus y. And if you do that, x plus y times x plus y, you would get x squared plus xy plus another xy plus y squared. Or simply 1x squared plus 2xy plus 1y squared. For the cubed, we won't work out, but this is what you get. Here's what you get for a fourth power, a fifth power, a sixth power, a seventh power. There are a number of things that you can notice about this pattern that's being created. For every single row, if we call this the 0th row, first row, second row, there is one more term in the row than there is a power. 0 plus 1 gives us one term, 1 plus 1 is two terms, 2 plus 1 is three terms, right? In the 8th row here, there are 8 terms. It's just 1 plus the power. Notice the symmetry. Do you see this? It goes 1, 2, 1, 1, 3, 3, 1, 1, 6, 15, 20, 15, 6, 1. Notice how the powers work. The powers always add up to the power of the row. 7 plus nothing is 7. 6 plus 1 is 7. 5 plus 2 is 7. 4 plus 3 is 7. 3 plus 4, 2 plus 5, 1 plus 6, nothing plus 7. The most important pattern, though, in this whole triangle is on the next slide. Before we do that, does anyone see a pattern and how we can make this row? Max?
The ones add together to 2, and then 1 and 2 add to 3, and then 3 and 3 to 6.
If you add two adjacent numbers, you get the next number. Do you see that? 6 plus 15 gives us 21. That is not a coincidence. That pattern holds for every single pair of numbers in this binomial expansion, which is what you use to create Pascal's triangle. So again, 4 plus 6 is 10, 15 plus 6 is 21. You could use Pascal's triangle to find all of the coefficients of any binomial expansion. Yay? This is really just a pattern recognition class. If you understand how the pattern works, this is really easy to do. Does anybody need more time on this slide? Do you see how Pascal's triangle works? All right, let's try an example then. So if I want to do x plus 3 to the 4th really quickly, all I'm going to do is make Pascal's triangle to the 5th row. Again, it's 4 plus 1. So this is the 0th row, first row, second row, third row, fourth row, fifth row. 10, 5, 1, 0, first, fifth. I want the 5th row, 4 plus 1. Okay, that gives me the coefficients for each of my terms. I will then write out my terms using another pattern. Ready to watch how this pattern works? This is your first term. This is your second term. And you're just going to do first term to your power times second term to 0 plus the next term has a coefficient of 5. I reduce the first term's power by 1 and I increase the second term's power by 1. Next term, 10. Decrease x's power by 1, increase 3's power by 1. Next term, again, 10. Did I do this right? 0, 1, 2, 3, 4, 5. Yeah, I did it right. X first, 3 third. No, I did. What? I went one too far. Oh, I'm sorry. I put the 0th row here. Ah, dingus, Mr. Lake. Ah, one row too much. Do. 1, 4, 6, 4, 1. I changed how I counted this year to try to make it easier, and I just messed myself up by doing that. I want this row, the 4th row, because this year I called this the 0th row, so we don't have to add 1 anymore. This is the 1st row, 2nd row, 3rd row. I thought that would make it easier, but then it just messed me up. X to the 0, 3 to the 4th. Don't need this row. It used to be I called this the 1st, 2nd, 3rd, 4th, 5th, 6th row, and then you'd have to add 1 to make it count. But if you called the 1st row 0, you don't have to do that. Then it really is just the 4th row. And make sure that when you're counting, the 1st row is the 0 row. Okay, so here are our coefficients. They should be 1, 4, 6, 4, 1. And again, you see those right here. 1, 4, 6, 4, 1. And then to get the terms for each one, you take your first term to your power times the second term to 0. And then for each term, you decrease the first power by 1 and increase the second one's power by 1. So this becomes 3, 1, 2, 2, 1, 3, 0, 4. And now this is just calculator work. 3 to the 0 is 1. 1 times 1 is 1. So this is x to the 4th. 3 to the 1st is 3 times 4 is 12. 3 squared is 9 times 6 is 54. 3 cubed is 27. Times 4 is, what is 27 times 4? 108. And now x to the 0 is 1. So 1 times 1 is 1 times 3 to the 4th. 1 times 3 to the 4th is, I believe, 81. It is 81. There you go. X plus 3 to the 4th power, done in 3 steps instead of having to double distribute, then triple distribute, then quadruple distribute. All right, does everyone see how the 2 patterns work that you need to get to this final answer? No.
No.
Do you want me to talk through this again, or you want to see another example?
No, so you just said it's learned.
Let's set you on your own. Okay. Does anyone need more time to write? Okay, well, I'll scaffold this next example. Okay, we want to do x minus 2 to the 3rd power. So now you have to tell me what is the 3rd row of Pascal's triangle. Again, don't mess up like Mr. Lake did. The 1st row is really the 0th row. This is the 1st row. Tell me what the 3rd row is. I'll give you 30 seconds. No, don't distribute it. Yes, that would work. It takes longer. Also, on the homework, there are some that are to the 7th power. You would never want to 6-tuplet distribute. Howdy,
Oh,
Palmer,
yep.
I guess. Palmer has those big sticky notes, huh? All right, what is the second row in Pascal's triangle? 1, 2, 1. What's the third row in Pascal's triangle? Awesome job, Reagan. 1, 3, 3, 1. Okay, so we will use that to write our answer. Our answer is 1 x to the something negative 2 to the something plus 3 x to the something negative 2 to the something plus 3 x to what negative 2 to what plus 1 x to what negative 2 to what. Tell me what the powers is for each of these terms. Remember, the first term starts high and descends. The second term starts at 0 and ascends. Give you another minute. Isn't this kind of fun? It's all patterns. It's all patterns. Red leather, yellow leather.
Oh my gosh. I did it right.
You think you did? In 30 seconds, you will find out. The answer will shock you in its symmetry of how patterned it is. Okay, let's see if we got it. What is my first pair of patterns? X to the third, negative 2 to the 0. Okay, that's all. You start here. I start at 3, and then this one always starts at 0.
Maybe I'm the first.
I guess. What is the next pair of patterns or pair of powers? 2 and 1. What's my next pair of powers? 1 and 2. What's my last pair of powers? 0 and 3. Do you see how the first power descends from your starting? The second power ascends from 0. And then the last thing you just got to tell me is what is that? Simplify each of these. What is 1 times x to the third times negative 2 to the 0? What is 3x squared times negative 2 to the first? What is 3x times negative 2 squared? What is 1 to the times x to the 0 times negative 2 cubed? You can use your calculator for the last part. Just tell me what those actually multiply out to be. I'll go ahead and walk just in case. I lost you, eh? One thing that I'll help you a little bit. Oh, yes, I think so. Yes, I think so. Well, I'll double check what we do after. But yes, I think both of those are right. All right, so if we do this, negative 2 to the 0 power is just 1. Anything to the 0 power is 1. 1 times 1 is 1, so this is just x cubed, or 1x cubed. Next term, -2 to the first is -2, times 3 is -6. Next term, -2 to the second is +4, right? Times 3 is 12. X to the 0 is 1. 1 times 1 is 1, times -2 to the third is -8. Ba, 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 ba. And there you go. You didn't have to double distribute, triple distribute, none of that. You can just go straight to the answer with the old Pascal's triangle. And to be honest, once you get good at this, you don't even need to write out Pascal's triangle. You'll just have that in your head. You'll just go straight from here to this line and then that line, and then you're done. 2 steps, no matter how big a power, you can do it in 2 steps. Do we want to do another one of these? Are you sure? All right. All right. All right. I think we end up doing another one later anyway, because I know what you're thinking right now. Mr. Lake, that's great and all if I want to do a binomial expansion, which I could understand why I would want to do that, right? Everybody loves doing binomial expansions. But what if you were at the grocery store and somebody said, hey, what's x plus 5 to the 7th third term? They don't want the whole thing. They just want the third term, right? What are you going to do? Sit there like a fool and be like, I don't know, I have to expand the whole thing? No, they'll be like, I don't have time for people like that. I just want the third term. Well, there's a pattern that you could use to find the third term, and that is a combination. It's this symbol right here, C. And to find the coefficient of any term, x to the n minus r and y to the r, you just take those values, n and r, and you take n combination r, which is n factorial divided by n minus r factorial times r factorial. You can also rewrite this as that. Those are the same thing. NCR is the same as parentheses n over r, but notice there's no over, there's no like fraction. This is literally n above r. That's a combination of n and r. And then that will tell you the coefficient for that term. And then you can plug in the actual values of the term to get the entire term, or if you just want the coefficient, that's fine. Anybody need more time to write on that? What? Is it cold? Freezing? I could tell the heater just kicked in. I could turn up the heat a little bit more. Turn it up the heat. All right, so let's do these by hand and then let's do a bit of practice. All right, so for this one, again, AC2, A combination 2 is telling me that N is 8, R is 2. So AC2 is just 8 factorial divided by 8 minus 2 factorial times 2 factorial. Or 8 factorial over 6 factorial times 2 factorial. You might reach for a calculator now. Don't. You don't need a calculator to do this problem, because we can simplify this. That's the same as 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. But in the bottom, I already have 6 times 5 times 4 times 3 times 2 times 1, right? So that I just cancel out 6 factorial with the 6 factorial here, And I have 8 times 7 divided by 2, which is 28. Isn't that cool? Again, this is the same thing. This is telling me that n is 10, r is 3. And so this is really 10c3, which is 10 factorial over 10 minus 3 factorial times 3 factorial. I should have done this in a different color. Oh, I could switch now. But that's just 10 factorial over 7 factorial times 3 factorial. And now I'm not going to write it all out like I did last time, but I know the 10 factorial and the 7 factorial can cancel, leaving me with just the lead terms 10 times 9 times 8 over 3 times 2 times 1. Again, for the 10, 9, 8, 7, 6, 5, 4, 2, 3, 1, the everything starting at 7 and afterward can cancel out with this 7 factorial in the denominator. So then what does that give us? That gives us 720 divided by 6. What is 720 divided by 6? Probably shouldn't need a calculator for that, but that's 120. All right, these last two will shock you in their answers. You ready to get spooked? Okay, here's some spooky answers for you. So this would be 7 factorial over 7 minus 0 factorial times 0 factorial. That's 1. 7 minus 0 is 7. Cancels out with the top. You get 1 over 0 factorial. 0 factorial is just 1. 1 divided by 1 is 1. All right, we'll do the last one in pink. Maybe this is more like a rose. Look at this. Do you see this? 8 minus 8 is 0. 0 factorial is just 1. 8 factorial divided by 8 factorial is 1. Isn't that crazy? But of course, we already do that. What this is telling me is that the coefficient, the second one in the 8th row is 28. The third coefficient in the 10th row is 120. The 0th, or basically the first coefficient in the 7th row is 1. We do that. And then the last coefficient in the 8th row is 1. We already do that, right? It always starts and ends with 1. But this one we can double check. This is saying the 8th row has the number 28 as the second term. So let's look at that. Nope, that's the wrong button. Pascal's triangle. Here we go. If we were to make, again, 0. Oh, does anybody need more time to write? Can I just clear this? All right. So we make 0, 1, 2, 3, 4, 5, 6, 7th row, 0th number, first number, second number. Look at that, is 28. 7 plus 21. And again, remember you count 0, 1, 2. You start counting at 0. That's the weirdest part about Pascal's triangle. You start counting at 0. 0 row, 1 row, 2 row, 3 row, 4 row, 5 row, 6 row, 7 row, 8 row, 0, 1, 2. Second number. Yay?
Yes.
All right, your turn. Oh, shoot. We forgot to do the calculator part. Okay. In your calculator. Stop share, reshare, full screen. In your calculator, you can do these really fast. You're just going to hit math. And then you're going to go right to the probability column. And then it's option 3. So I say that. And then it'll ask you for your two numbers, 8 and 2. 28. Isn't that cool? So for this one, again, for the parentheses one, same thing. You do math, go right to the probability column, option 3, 10 and 3. It's 120. That's option 3, NCR. All right, so try these 4, ideally by hand first, then in the calculator to check your answer. Oh yeah, hold on, let me see. Oh, because yours, okay, let me see. It doesn't have blanks, it just has like. Okay, so for you, you're gonna have to type in, you would have to type in like 11, then go in there, and then 5. Oh, okay, so there you go, that's what you'll have to do. Yeah, you got the same thing, you have to do that. Who else had one that was like that? You, so what you'll have to, did you figure it out? Okay, so what you'll have to do, if you want to do 11 CR5, you have to type in 11, then go grab it, and then 5. So 11 CR5. Yeah, you'll have to type it in like that. How are we doing on this side? Yay. I didn't start the timer. What a yahoo. I'll give you 2 more minutes. C and D, you should not need a calculator for. Am I still showing whole screen? Oh yeah, all right, so you should have got, hopefully, for the first one, that 11C combined with 5 is 462. You should have gone for the next one. That 9 combination 2 is 36. You should have gotten 1 and 1. And notice that if you draw out your Pascal's triangle, 0, first, second, third, fourth, 5, 6, 7, 8, 9th row, that the 0, first, second number is really 36. So now, when you're doing a binomial expansion, we can do this tomorrow. You can either write out Pascal's triangle and plug in, or use the combination to get every coefficient of that row and then plug in. You don't have to actually redraw Pascal's triangle. All right, so we'll make this bell work tomorrow, and then we'll have you try one, and then, ooh, another? Oh, we got plenty of practice problems we could do. I don't know if we have to do it, but we got plenty. Yes,
I finished my quiz.
the test?
Yes.
Got it.